Hmm. So last class we discussed about overloading the arithmetic operators. We had overloaded all the arithmetic operators, and few arithmetic operators to be loaded have been given to you as assignments. Okay, I hope you are able to do that assignment. Just answer me with thumbs up, thumbs down. Overloading arithmetic assignments, arithmetic operators. Are you able to do that? Or if you have any doubts, any queries before I proceed further? Yes, Harry. Yes, Harry, tell me. Tell me. Mhm. No, 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 no. Are you trying to overload C out? You can't overload C out operator right now. I have not explained you how to do that. Right now, till now, I have only explained you about arithmetic operators and arithmetic binary operators and unary operators. In unary operators, prefix and postfix. Okay, only those things, nothing else. And yes, it could not be clubbed with C out because C out is a different way. You know, that's a different mechanism. I have to explain you separately. You can't do it with C out. Hmm. Yes, tell me. Hmm. Yes, that's right. Absolutely correct. In the prototype also you have to give int as argument. No, 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 not vice versa. There's a concept, and then that has to be done in a particular way. And that particular way is that one of those is taking integer as an argument just for the purpose of differentiation between postfix and prefix. And I will actually not pass any argument. Okay? Very nice. Now, here we are. Last class, I told you about different about what is polymorphism. I told you about what we will be overloading. We'll be overloading all kind of arithmetic operators. We'll be overloading all kind of relational operators and many more things. Some arithmetic operators: addition, subtraction, multiplication, division, modulus, increment, prefix, increment, postfix, decrement, prefix, decrement, postfix. These nine have concepts have been given to you, and you were given an assignment to do that. Okay. Now we move on today to our next category of operators to be overloaded, and these are going to be relational operators. Now there are seven relational operators that we have to overload: less than, greater than, less than equal to, greater than equal to, not equal to, and not. Where not is the unary relational operator, rest are binary relational operators. Okay, the best way to learn these relational operators is through programs. But few things I'll tell you about this. When you overload any binary or unary relational operator, you will be writing operator overloading function, and that operator overloading function will return boolean, true or false. That's the only thing you should understand. Okay. Second thing, the data type of the object on the left and the object on the right should be same. So if you put it here, if you overload a relational operator, suppose you're going to overload a less than operator. So you'll have an object on the left and an object on the right. And object A, suppose on the left, and you have object B on the right. Okay. Object A and object B. So let me put it like this. You are overloading object A and comparing with object B. The important things is to notice is this is operator to be overloaded. Okay. Second thing, when the operator overloading function will be invoked, let me put it here in text. Watch. When the operator overloading function will be invoked, then the function that you write will belong to object on the left. Same thing you've seen earlier in overloading arithmetic operators. So this is your object on the left, object A. Okay, so your operator overloading function will belong to object A. Okay, and another thing, the object on the right will go as argument. Okay, the object on the right will go as argument. This one is the object on the right. Okay, this will go as argument. Okay, and third and final thing about this is that the operator overloading function will return Boolean. The overloaded function will return Boolean. It is as simple as this. Okay. Give me thumbs up that you're able to understand all the 3 points so that I go ahead now. Nice. Very nice. Let us see how it is implemented. When you implement any of these, then somebody please share the Jamboard link. I'll wait. I'll share it with you guys. The Jamboard link. There it is. We are going to overload, start with less than and greater than operators. These operators can also be overloaded to input. Overloaded to perform input and output operations. That we will see later on, not now. Right now we'll just stay here with the relational operators. Let us see how the relational operators are overloaded, and we'll see a program for this. Okay, we will see overloading less than operator. This one. Okay. So I'm going to open up this program for you. We have a class here. The class in which we have a distance in feet and float inch. This is a distance. And I have a 0 argument constructor. I have a 2 argument constructor. I have a copy constructor as well. Then I have a getDist function which will take distance from the user. The showDist function which is going to display your distances, objects as constants. Constant is a qualifier here. Look at this. This is the operator overloading function for less than operator that we are going to implement. Let us elaborate this a little bit. Now, there it is. The operator overloading function that we have declared in our class. Here, this less than operator is the keyword, you know that, okay? This less than is the operator to be overloaded. Operator to be overloaded. This less than. and the operator is a keyword which tells that okay, this is operator. Now this will be done like this. Let me go to the main function first, then I'll come back here. Let us open the main function. The main function, we declare d1 object. So this d1 object will invoke a zero argument constructor. All of you understand? Because we have created this object with zero arguments, it will invoke a zero argument constructor, and zero argument constructor looks like this. Constructors will follow till the end of the session. So this is a constructor for zero arguments. Constructor zero. Okay, there it is. This is the constructor for zero arguments. I have watched this carefully. In line number 6 here, I have done distance d1. So d1 is an object being created with zero arguments. So it invokes a zero argument constructor. And the zero argument constructor gets invoked. And when this zero argument constructor gets invoked, it initializes the feet to 0 and inches to 0. What is feet here? Well, feet is the private member. Inches are the private member. Both are feet and inch is private member, and both are initialized to value 0 and initialized value 0.0. This way of initialization of the private members through the operator overloading function is called initializer list. Okay, zero argument constructor have initialized the feet and inches for object d1 to 0, 0. Then we created another object d2 where we are giving two values, arguments 7 and 7.77. So a two argument constructor will get invoked in this case. All of you know that? Here it is. Two argument constructor gets invoked. So from here, when we declare object in line number 7, then d2 gets 7 and 7.77. These two things as arguments. And these two arguments go into your two argument constructor. 7 comes into feet, ft, and 7.77 comes here. Then these two values are further initializer list through the initializer list. These two values 7 is initialized to private member feet, and this value 7.7 which came from here to here, which is further initialized to inch, a private member. Okay, this way the two argument constructor initializes the second object also. Both the objects are now initialized. Yes, Harry? Structure. I mean, you want to say instead of integer and a float, you wanted to keep a structure there. But it will be possible. It will be easy. In fact, just an additional dot will be there. So we'll do that. That also I'll show you. So I call a get distance function here. So see, one of the two distances d2 is initialized by the constructor. Other one contains 0, 0, all zeros, isn't it? So we call get distance function. The get distance function, when called, works like this. You ask the user to enter distances in feet and inches, and the distance is entered in feet inch. And when the distance is entered in feet and inch, there you see feet and inch, both are stored. Both are stored in the private section. So it's easy. So you have both the distances, one initialized through constructor, another object initialized through entered by the user. Then show this will display both the functions. Look at the show this. Look at how we are displaying. So we have used this bracket, the value, the feet sign, hyphen, the inch value, and the inch sign followed by bracket. This is how we display it. Now, this is what we are all about. This is why we came here. D1 is an object, D2 is object, and this is how we are calling it. The operator overloading function being invoked here. And watch what happens here. So I have this, the operator overloading function being invoked through these two. What happens now? Watch this carefully. Now D1 less than D2. So this less than is the operator that is going to be overloaded. operator less than. This overloads the operator. So this is your operator to be overloaded. Fine. Now this is the object on the left, this is the object on the right. The object on the right, this one. Answer me. If I am correct, you say yes, thumbs up. If I'm wrong, you give me thumbs up. The D2 goes as argument. Is it correct or not? D2 object on the right goes as argument. The answer is no. No. Look at this sign. Look at this. It means D2 has not gone as argument. It means D2 is being referred from here. No new. If you pass D2 as argument, then a copy of D2 will go as argument. And another object D2 ki copy, D2's copy will be created here. So we should not do that. Because we have used the reference sign here, that means it is a reference to D2. So this is you are referring to original D2. You are going to refer to original D2. You are going to refer to original D2. Okay. You are not passing D2 as argument. You tried to pass D2 as argument, but the function says I'll accept by reference. When the function says I'll accept by reference, that means no copy of D2 will be created to be passed as argument. Instead, you will refer to original D2. Because why it is implemented like this? Remember the concept we used in copy constructor, where I told you that there was no need to create additional copy. Similarly, here also we have to compare D1 and D2. We just have to compare D1 and D2. We don't have to create a new copy. We don't have to process any data here. So it is just a reference to D2. I would like to add one more comment here for your understanding. A reference to D2. No new copy of D2 is created for passing as argument. No. Okay. Then there is another thing that we see here. Constant. This CUNST. What is the CUNST all about? Yeah. CUNST. This is called qualifier. This is called qualifier. Okay. What it will do is it will qualify. It will qualify the corresponding. No, I will not call corresponding. Qualify the reference to D2 to be treated as constant. Yeah. So it will be qualified to be treated as constant. What will be qualified to be treated as constant? Well, the corresponding object that is with constant, this one will be used as constant in the whatever function we have. And there is another constant here. What is that for? Well, before I tell you that, let me tell you the whole function that we're talking about. This whole function, when invoked, this operator overloading function, when invoked, listen this carefully, belongs to the object on the left, and the object on the left that we have left of the operator. This is the operator that is getting overloaded. This is the operator that is getting overloaded. The object on the left of this is this D1. The D1 is, which is here, is the object that is overloaded. This operator overloading function, when invoked, belongs to the object on the left. So the whole operator overloading function belongs to the object on the left. I told you this. If you're overloading a relational operator or an arithmetic operator, then the operator overloading function will belong to the object on the left. And the object on the right could be passed as argument or could be referred to be used as argument. Okay. Now, talking about the constant that you have towards the end. What is that left out constant that you have here? I mean, this. Let's talk about this now. So this is your, this is, yeah. This is also a qualifier. It will treat the object to which the function belonged to be qualified and treated as constant in this function. That means the internal CONST treats the argument, so the object that is argument, treated as constant, qualified and treated as constant, whereas the constant outside of the argument list makes the object to which the function belongs to be treated as constant. That means both D1 and D2 will be treated as constant in this function. Why not? After that, it is a relational operator. It is just comparing. It is just going to compare and give you Boolean true or Boolean false. It is not going to alter the value of D1 or D2. Therefore, both the concerned objects are going to be used as constant in the called function, right? That's why when we call this D1 and D2, let's look at this definition. It says that the argument being referred to as the object being referred to as argument will be treated as constant, and the object to which the operator overloading function will belong will also be treated as constant. The function will eventually return a Boolean true or false. Okay, now let's see how it is implemented. There it is. Well, look at this being referred to D2 and qualifying D2 to be treated as constant, and this CONST ensures that the object on the left that happened to be D1 in our case is also treated as constant. This function is finally going to return Boolean. How? Well, the logic is applied. Convert all the feet into inches, and then compare, return true or false. That's a simple logic you can implement. So it will return true or false, and now you are able to compare the objects. See, had it been integers, had it been floating point values, had it been strings, or had it been some characters, you would have straight away compared it. But objects, the object have its own architecture. What you keep in the private section? Well, right now I have only feet and inches. Maybe you can have anything in there. So the C++ doesn't have logic intelligence enough to understand and compare what you have kept in the private section. So we have to implement our own logic to compare our object. So therefore, to compare our own object, we need our own logic, and then that logic we will implement in the operator overloading function like this. And then once implemented successfully, you will be able to compare all the objects like this. This is the way you will use less than, greater than, less than equal to, greater than equal to. four kind of, even equal to, not equal to, all the six relational operators could be implemented in the same way. Is that clear? Let us run it now and see how it works. We have a make file for it. Okay, there it is. We build, we build it. So build is happening and done. Okay, let's run it. First, okay, enter distance. I say 7 feet, 7.77 inches. Okay, oh, D2 is less than D1 because it was checking for greater than, not D2 is less than. Again, implement, you enter 9 feet, 9.99 inches. Well, D2 is less than D1. D2 was 7.77, we had given here. This D2 was 7.777 and D1 we have given 9 point something. So D2 is less than D1. So this is how we compare less than. You know? So we can also put else if and compare greater than, overloading operator for greater than, else if equal to. We can put all these. Mhm. I hope you are able to understand the concept that I'm giving here. It is about only going to concept. You can compare anything. If you look at one very interesting example we have, sorry, assignment we have for this, I'll show you that. Watch. Assignment. Polyform. This is for addition operator, less than operator. Watch this. Very interesting. Write a class called time. No. For the above rectangle overloaded, there is a write a operator overloading function for overloading addition operator. The function would add two rectangles. Okay, that was for addition. Here we are going to compare two rectangles. So how would you compare two rectangles? Well, there could be any logic that you can implement. For suppose you find the area of the rectangle and compare whose area is bigger. You know, or you can do is find the length and the breadth, and sides. Then write an operator overloading function for overloading assignment operators. Ooh, look at this. This also is very easy. Well, everything will be implemented using same logic. So you had 9 programs in arithmetic operator overloading and 6 programs in a relational operator overloading lined up. So once you implement this, you'll be able to understand the concept. Okay. So all the relational operators, less than, greater than, equal to, not equal to, less than, greater than, less than, not equal to, all the relational operators will be implemented using same logic that we have discussed just now. Yeah. Okay. There it is. Any doubts, any queries you have, you can ask me now. Please go ahead. Yes, Harry? Mhm. Yes, we can overload. Your question is, can we overload the ternary operator? The answer to your question is yes. But that will be little complex. That we'll do towards the end of operator loading. What's the second question? No, these are qualifiers. Both C and C++ are strongly typed languages. Once attributes and data type of data is set up, it could never be changed. When you create a function and make a function call, you are creating new formal arguments or references. They will always treat the value, the placeholder, the identifier as constant if qualified, and it could not be changed, not even using pointers. These are strongly typed languages. Good question. Anything else? Anybody else? Hmm. Now I want to know like how many arithmetic operator loading functions you've written out of 9. Come on, give me the numbers. Give me the numbers in the chat. All of you. 9 में से कितने हो गए? Ritesh has done very good. Ritesh, I like that. Abhinandan 7. 7 out of 9. Harry 6 out of 9. Mhm. Aman. Aman. Aman is way behind, not yet started C++. He's doing good. So, nice work. You should, Vishal, any updates? Okay. All of you should implement the relational operator overloading functions also. Okay. There is more to it in the operator overloading, but I don't want to confuse you by giving you too many things here. So tomorrow I'll come back and overload the third category of operators. That is insertion operator that you use with C out. Extraction operator that you use with C in. That we will overload in the next session tomorrow. Right? So that's all I got for today, and I hope that you are able to answer the questions, understand the concept discussed here. For any more clarification, use the discussion forum to put your queries there. Okay? So take care. Bye bye. Thank you very much.